Hi, so this video is just going to recap all the little lessons in straight line at higher, right up until the point where we start talking about the special lines. So we're going to cover things like collinearity, m equals tan theta, midpoint formula, distance formula, how to get a perpendicular gradient, and a wee chat about vertical and horizontal lines. So let's go. So first thing I teach is collinear points. Collinear means that they all lie on the same line. So for example, if I had 3 coordinates from on a straight line, let's call this A, let's call this one B, and let's call this one C. They are collinear because they all lie on the same line. So what's special about them is that the gradient for A to B should be the same as gradient for B to C, or A to B and A to C should be the same. If those gradients aren't the same, then these aren't straight lines at all, and what you maybe have is something that goes like this from A to B and then takes a slightly different direction to C. So it's all about playing around with your gradient formula. Okay, so to show that 3 points are collinear, I always start with a little sketch just to illustrate what's going on and to work out, well, do I know what gradients I'm finding? So what we're going to do is we're going to find the gradient first of all, part A to B, and then we're going to find the gradient of B to C. And if the gradients match, then they're collinear. So gradient AB, so the notation I do for gradient is M with a little AB down below. So gradient AB will be 4 minus minus 2 on the top, so 4 plus 2, and 4 minus minus 4, so 4 plus 4 on the bottom, which gives us 6 over 8, which simplifies down to 3/4. Let's go find gradient of B to C. So that will be 7 take away 4 on the top, 8 take away 4 on the bottom, which gives us 3 over 4. So because these gradients match, I know that these points are collinear, and then to conclude, we just have to write that. So write since gradient AB equals gradient BC equals 3/4, A, B, and C are collinear. Excuse my handwriting here. And that's all you have to do. And obviously if those gradients didn't match, then they wouldn't be collinear. Dead simple. This style is a bit trickier though. It tells you that the 3 coordinates are collinear, so we had to find a missing value. So we're going to do the same again. We're going to do F to G as part 1, and then we're going to do G to H as part 2. Okay? So gradient F to G will be 3 minus 7 on the top, and minus 1 minus 3. So minus 1 minus minus 3. I always have to write it like that in the class for my pupils first of all, just to show that it becomes a plus. And then that gives us minus 4 all over 2, which simplifies just down to negative 2. Then I'm going to do the exact same for the next bit, and bear in mind there'll be a letter involved here. So gradient of G to H will be P minus 3 on the top, and 2 minus minus 1 on the bottom, which becomes 2 plus 1. Which gives me P minus 3 all over 3. Now because I know these are collinear, I can put these two things equal to each other. I can say P minus 3 all over 3 equals negative 2. I can then cross multiply, so times the other side by 3, so P minus 3 equals negative 6. Move minus 3 over, so that becomes minus 6 plus 3. So P has the value of negative 3. Okay, so that's how you do that one. There are other methods, I just think that's the way that always jumps out to me, as to make some little equations. The next formula we come up against at straight line is the alternative gradient formula. So this one is called m equals tan theta. And we know you're going to use this one when there's any mention of angles. What this formula creates is it finds the angle between your straight line and the positive direction of your x-axis. So let's have a look. So m equals tan theta. Theta is just a Greek letter for angle. So theta is anti-clockwise angle from the horizontal axis. So you see them drawn here. So it's always the angle from the x-axis going round the way anti-clockwise. So it can be acute or it can be obtuse up to 180. So that is the angle we will be finding out. So if you've got a positive sloping line, you should have an acute angle. And if you have a downward sloping line or a negative gradient, expect an obtuse angle. And there's 2 different styles of questions we can give you for this. We can give you one where we ask for the gradient, or we can give you one where we ask for the angle. Okay, so both these diagrams want to find the angle that the line makes with the positive direction of the x-axis. So it's this angle here I am after. So the first thing I'm going to do is get my gradient. So my gradient will be 3 minus minus 1, turns into a plus 1, all over 8 take away 2, which is 4 over 6, which is 2/3. So because I know my gradient is 2/3, I can say, right, well, tan theta equals 2/3. At this point, you go to your calculator and you do shift tan of 2/3. This is not an exact value one, okay? Sometimes it is, but this one is not. So you do shift tan of 2/3 and you get the answer of theta equals 36.7 degrees. And it's entirely up to you if you want to round that to nearest degree or leave it to 1 decimal place. But that is the angle that that line makes. Let's do it on this one. Now notice this one here is actually doesn't meet the x-axis at all. So what you're really finding is if you extend your line, well, maybe hopefully a bit straighter than I've done, we are finding this angle here. It's a downward sloping line, so it's a negative gradient, and we're expecting an obtuse angle. So first of all, let's get the gradient. So my gradient here is 5 take away 8 over 7 minus 1, which is negative 3 over 6, so negative 1/2. So we say, right, tan theta equals negative 1/2. Now, using your all sine tan cos table, tan is negative, so we're not using all in tan this time. We normally would use sine and cos, but remember we're only looking for this angle here, which is less than 180, so I'm not going to bother using the cos box either. Your acute angle, go to your calculator and do shift tan of 1/2. Now then remember, sometimes this could be exact values. Just the 2 examples I've pulled aren't exact values. So my acute angle comes out as 26.6 degrees. So to find the angle in my diagram, theta will be 180 less 26.6 because you are using it in the sine quadrant, which is when you take off 180. And as an answer, that gives us in 153.4 degrees. Now, this could be exact values, as I said, and you would have to do that without a calculator, but I just thought I'd show some on a calculator. So that is the first style. The second style is we give you the angle and we ask you what the gradient must be, and this one's dead straightforward. You plug in m equals tan theta. So your gradient is simply whatever tan 82 is. And you go to your calculator and type that in. And it gives us 7.11, so 7.1. So your gradient in this case is 7.1. It's quite a steep line. Okay, so just make sure if they give you that one, they always give you that angle there. There could be the instance that they give you the angle on the other side, but remember we always need the angle from the x-axis, so you'd be using the 82. Okay, so that is the m equals tan theta formula. The next thing we teach at straight line is we teach you how to find the distance between 2 points, which comes up an awful lot as circle, and we teach you the midpoint formula. And I kind of put these two together into one lesson because they're quite straightforward formulas and it shouldn't take too long to master them. So let's look at the distance formula first. Now, we teach you at National 5 in questions like this how to find the distance between 2 points. And this is your fallback if you can't remember the distance formula. And a lot of the times I actually prefer this method because I think it's quicker than writing out the formula. So if I gave you 2 coordinates, 1, 2 and 5, 5, I would do a quick sketch. I don't even need all that x and y axis around. I just need 2 random points in a line. And what you do is you compare your x coordinates and think, right, how far is it from the 1 to the 5? Well, that's a distance of 4. And how far is it from the 2 to the 5? Well, that's a distance of 3. So the sides in a right angle triangle would be 3 and 4. So to then do Pythagoras, let's call this d, you would say, well, d squared equals 3 squared plus 4 squared. D squared equals 9 plus 16. D squared is 25, and we all know the square root of 25 is 5. So the distance between those 2 coordinates is 5. Now, let's do this again. We're going to do it a different way. We're going to do it the formula, which you might think complicated. So this is the actual distance formula, and it's one of those ones, it's not given to you, you have to memorise it. But the distance formula is the square root. So whereas we find in Pythagoras, we find the square root in the last line, they just stick it all over the full formula at the beginning, just to save a line of working. So it's the square root of, this is your x's, this bit in the bracket here, this is your x's subtracted. So that, remember my last picture, I found the distance between the 2 points, the 2 x coordinates, that's just the same. You're looking for the gap between the x's, then you square it. And then this bit is the gap between the y's, and then you square it. And then we put all that under a square root, which is just what I kind of did, but I did it more visually. So following the formula, the distance here would be the square root of, remember your x's are these two numbers. So it would be -4 minus -2. Just watch all these negatives going on. Plus your y's would be the -7 and the 5. So that would be -7 minus 5 all squared. And working that out, well, -4, that becomes a +2. So that's -2 squared. That's -12 squared. Good we remind that any number in maths squared is a positive number. So this gives us 4 plus 144, which is the square root of 148. And at that point you have to go to your calculator there and work out what the square root of 148 is, which is 12.16. Let's say 12.2. So that distance would be 12.2. Now remember I said if you forget the formula, I prefer the other way. So here's a quick rendition of what I would have done the other way. I said, right, there's -25. And I don't care that this isn't accurate at all. It's definitely not accurate in terms of the way I'm sketching it. I say, right, there's my triangle. And I say, right, from -2 to -4 is a gap of 2. From 5 to -7 is a gap of 12. So I would be doing the square root of 2 squared plus 12 squared. Now, is that not just what I had there, but I did it a heck of a lot quicker from the diagram. And I think that method also kind of eliminates the process of you messing up your double negatives and things if your basic integer work isn't too great. Anyway, just a suggestion. Don't necessarily need the formula. We're not going to mark you down for which method you use. Next comes the midpoint formula. Now, midpoint, remember at maths, first year maths, we teach you the median. Hey diddle diddle, the median's the middle. Very much the same here. And there's two ways to find the middle value of two numbers. If the gap is something you can spot, you find the gap and you half it. And you add it on to each number. Or you just add the two numbers together and half, which is basically finding the average of those two numbers. And that's the way we do the midpoint formula. We find the midpoint of each of the points. So the midpoint formula here just tells us that we add the x's and half them. And then we add the y's and half them. And it's one of these ones I don't necessarily always write out the formula. So the midpoint for this first example would be -2 plus 4 all over 2. And then 7 plus 9 all over 2. And just take it left to right in the way it comes. So that gives us 2 over 2 for the first side. And then 16 over 2 for the second side. Which gives us an answer of 1... Oops, my pen's not working. Gives us an answer of 1/8. Now, my pupils don't always show every single stage of that working. They get a bit used to do it and they're doing it a lot quicker. So the second one would have -6 plus 6 over 2. And then 3 plus 4 all over 2. Well, -6 plus 6 is 0. Half is still 0. 3 plus 4 is 7. 7 over 2 you can leave as 7 over 2. Or you might want to write it as 3.5. I would leave it as 7 over 2. And you can have fractions as your midpoints. So that was your midpoint formula. And we need the midpoint formula for one of the special lines that we'll meet further on in the course. So the next thing we then teach is we start talking about perpendicular lines. Now, perpendicular is a nice big fancy new higher word. And what perpendicular means is if two lines meet at right angles, then they're perpendicular. So what you have to think of, remember when you were taught in first year about a rhombus or a kite? Their diagonals were perpendicular. They met at right angles. So that's a new word you need to learn. Now, quite a lot of the times we know the equation. We know that two lines are perpendicular. We know the gradient of one line. We want to get the gradient of the other one. Or sometimes they ask us to show that lines are perpendicular. So to do that, we use this yellow formula here. So this is one you need to memorise. If your first gradient times the second gradient gives you an answer of -1, then they are perpendicular. And there's a lovely wee trick to this one, and people can visualise really quickly that lines are perpendicular based on their gradients. But you need to remember this wee formula because this is what you need to write as your proof part. So I'm going to show you an example. Here are two lines drawn here. The red line is the line with the equation y equals 2/3 x. And if you take your minds back to the very first introduction of gradient, the very basic introduction of gradient was that your formula is your vertical number over your horizontal number. So its gradient of this line is 2/3. Now, if we do the opposite of that and flip our vertical and horizontals, we have this blue line here, where our vertical became 3 and our horizontal became 2. And that makes a downward sloping line, so a negative gradient, and it's got the inverse fraction. So my first line has the gradient 2/3. My other one has -3/2. Now, can you spot that these fractions are just flipped upside down? One's positive, one's negative. This will always happen when you've got perpendicular lines. And if I take the two gradients of these lines and multiply them, well, the 2 and the 2 will cancel, so that's just 1. The 3 and the 3 will cancel, so that's just 1 and 1. So you're left with 1/1 with a negative out front, which is just -1. So if two lines are perpendicular, then their gradients multiplied gives you -1. But visually, you're going to look at them and say, oh, that's just that fraction upside down, and one's positive, one's negative. So you can see they're perpendicular, but the proof has to come from that little statement, writing because gradient 1 times gradient 2 equals -1, lines are perpendicular. So let's have a look at some questions in action. So first of all, I just want to practice finding perpendicular gradients. So my notation for perpendicular gradient is I write M with a little kind of perpendicular corner down there. Other teachers might write M with the word perp underneath. Okay, so that's their notation for perpendicular gradient. So perpendicular to 6 is, think of that fraction, 6 times what is -1? Well, that's going to have to be -1/6. And the trick really is to flip it and change the sign. Now, if you're not sure, then 6 can always be written as 6/1. Flip that gives you -1/6. Similarly even, if I've got gradient -4, to flip that, well, that's 4/1, so the new one would be 1/4. That was negative, so my new one stays positive. So that's perpendicular to that one. If I give you gradient 1/2, let's flip it. Well, 1/2 becomes 2/1. So we don't need the over 1, we're just going to write 2. And that one was positive, so the next one is negative. And on this one, I forgot my wee notation there for perpendicular gradient. And then for this one, perpendicular to -3/4. Well, it's already negative, so my new one's going to be positive. And flip your fraction, it's 4/3. And that is the kind of wee trick. Look at it, flip it, change the sign. So what I want to do is find the equation of the line through the coordinate 2, -4 that's perpendicular to this one. First thing I have to do is rearrange this line. You always have to have equations of a line, if possible, in the format y equals mx plus c. And it's a standard question at National 5. So I'm going to keep the 4y where it is. I'm going to take the 2x over and make it negative. And I'm going to take the 10 over and make it positive. Then I'm going to divide everything through by 4. So that is, 2/4 is a half, so I'm not even going to bother writing 2/4. So that is -1/2 x plus 10/4 is 5/2. Now that's really irrelevant, so it doesn't matter about that bit. So the gradient of this current line is -1/2. Now, whenever I'm finding the equation of a line, I have a strict format to write out. I get my pupils to write point. I get them to write gradient. And then I get them to write equation, which I write as that for short. So the point I'm going to use is -2, 4. The gradient that I had of this line, so this line has a gradient of -1/2. I want the one perpendicular to that. So perpendicular to -1/2 is positive 2/1, so just 2. So the equation will be y minus b equals m bracket x minus a. This is your coordinate AB. So it'll be y minus 4. Equals 2 bracket x minus -2, so plus 2. Let's multiply that out. So 2x plus 4, move that 4 over and become plus, so 2x plus 8 is the equation of the perpendicular line. Okay, so last style is to prove that these two lines are perpendicular. So let's call this first one line 1. X plus 3y plus 6 equals 0, and call this one line 2, y equals 3x minus 1. Right, so the gradient of this line is 3, just from reading it off. I need to rearrange this one. So if I move it over, I will have -x, -6. Divide by 3 would be -1/3, x minus 6. Now I can tell just from looking at that, 3 flipped would be 1/3 with a negative to make them perpendicular. So I can tell just from looking, but the problem that pupils find is, oh, how do I actually communicate they're perpendicular? So you write, since gradient 1 times gradient 2 equals -1. And if you really wanted, you could then put in that was -1/3 times 3 equals -1. Lines are perpendicular. Okay, and you need to have that wee bit there to do the actual proof bit. You can't just say lines are perpendicular. Okay, then after that, I do a wee chat about vertical and horizontal lines, because sometimes when we're finding the equation of a line, you'll come out with a gradient of 0, or you'll come out with an undefined gradient, and pupils will really struggle to visualise what those lines are. Now, they are either vertical or horizontal. So remember, a horizontal line goes that way, like your horizon, like the sun, and vertical goes up and down, like your vertical blinds in your house, at your window maybe. If you have a gradient that's horizontal, that has a gradient of 0. And if you have a vertical line straight up and down, then that gradient is undefined. There is no answer for that. Okay. Now what I've got is I've got these lines illustrated on the x and y axis on the next slide. So this red line has a gradient of 0. And every single point on that line goes through whatever my a value is. So I maybe want to go change that value of a. And I'm going to make that coordinate a 3. So every single point on that line is along something up 3, along something up 3. So that means it always has a y coordinate of 3. So its equation is simply y equals 3. Now my vertical line is very similar. If I told you this was 4 boxes along, every single point on that line would be along 4, up something, along 4, up something, along 4, up something. So the x coordinate would always be 4. So that one has the equation x equals 4. And you kind of need to always remember that. So anything that's vertical always has a matching x coordinate. Anything horizontal always has a matching y coordinate. Okay, so and what will happen is if you maybe had the equation of line and the gradient was 0, your equation would become y minus b equals 0 bracket x minus a. Oh, that whole side would just become 0. And you would have a line y equals a number. And some people get put off by that because they think, well, I can't have a gradient of 0, what am I going to do? But that's okay. When you have an undefined gradient, that'll be when you're maybe working through and you have 6 minus 2 on the top and 3 minus 3 on the bottom. So because you end up with a 0 on the bottom, that's when you have to realise that's not just 4, it's not 0, it's an undefined gradient. So that anything with a 0 on the bottom of a fraction you can't do. So that's an undefined line, and then you have to have that knowledge of knowing, well, that one doesn't have a gradient at all, it's undefined, that's just a straight old vertical line, x equaled. Alright, and what would have happened there is I probably was using the coordinates. What would that have been? That would have been the coordinate 3, 6 and the coordinate 3, 2. And you should spot, oh, wait a minute, they've both got an x coordinate of 3, so it's just x equals 3 for that line. So let's look at a couple of examples you might have to do. So let's find the equation of the line parallel to the y-axis through 3, 1. So I'm going to draw a little sketch. There's the x and y-axis. Parallel to the y-axis means it's an up and down line. It's parallel to the y-axis. And it's possibly going through the coordinate 3, 1. Now every single point in that coordinate is along the same. So they're all along 3. So this equation has x equals 3. That's the equation of that line. And I can't do that without a sketch. I definitely think sketches are the way forward. Second one's the one perpendicular to x equals 5. So the line x equals 5 was like this. A vertical line, always had the x coordinate 5. If I want the one perpendicular to that through 7, -2, well, this is going to look something like this. Because there's a possibility of where 7, -2 could be. And because it's perpendicular, so I've drawn it at right angles with my previous line. And if it's going through 7, -2, then that means it's always down 2. So if it's always down 2, this one has the equation y equals -2. And they're just wee random bits that can be thrown in. So there's loads in that video, I know that, but it's just all the little bitty bits that you need to be able to do the main big straight line questions. Thanks for watching.